So today we're going to talk about graduating from data labeling to AI data development. Chris Glaze, principal research scientist, analyst from product, and this has been a joint research effort and product effort. So, I'm going to go through some theory, some customer examples, and then Andrew's actually going to show you what we're baking into the platform. I'm going to begin by going over some first principles, and I want to give you the takeaways first. So, principle number one is that subject matter experts still define what good looks like in a Gen AI world. Right, that's our big bet. We don't think that's going away anytime soon. And we can think of data labeling as kind of a special case of an operation that's needed for Gen AI. It's necessary and sufficient for predictive AI. If you have a classifier and you have a document can be choice A or choice B, that's a relatively simple data labeling problem. You have a bunch of documents, label them as A or B. For generative AI, you need a wider array of operations. And labeling is still relevant, but it's insufficient. So, before I go into the meat of this, I want to go over some basics. So we have data operations for AI training and evaluation. Labeling is an example of an operation. And then we have user AI workflows that sequence these operations to enable the development of data for AI. And that's really, for example, the point of a web application is, you don't just hand subject matter experts an algorithm. You enable them to interact with the algorithm in elegant ways that make their lives easier. And that's really fundamentally a UX problem and a workflow problem, something that we're also really focusing on the research team. The company was really founded on research that was published almost 10 years ago now, this concept that we call programmatic labeling. And so it's really scalable training data development with subject matter experts in the loop. And I'm showing you this paper that actually Alex, our CEO, published in 2016, partly for some historical perspective. So these are ideas that we started to develop around the same time that transformer architectures were developed. So that's really what fuels Gen AI. And so the idea has been around for a while and is originally applied to predictive models. And the concept is relatively straightforward. So, with predictive models, traditionally, to label data for predictive model development, you need a workforce of people to do it kind of sample by sample. So if you have 1,000 different documents, maybe you need to hire 10 or 20 people to label them as A or B, and that can take several hours. In real-world business use cases, often you have a much larger set of documents and more complex decisions to be made. And that can take days, weeks, months, and subject matter experts are expensive. How can we accelerate that process? Well, the method that was published almost 10 years ago was this concept of programmatic labeling with labeling functions, in which you can take a much smaller workforce and have them write heuristics, kind of noisy rules of thumb that can then be aggregated to approximate a really well-developed training set that can then be used to train a downstream predictive model like a classifier. And so you get really big efficiency gains with this kind of approach. So instead of a big workforce, you have a much smaller expertise workforce that writes what we call labeling functions, kind of data operator. And you can get model development in days that would otherwise take months. So this is our bread and butter for predictive models. It's been proven out repeatedly on a variety of customer use cases using a workflow that takes this concept of programmatic data labeling and puts subject matter experts in the loop with what we call label error mode analysis. So subject matter experts write labeling functions, they look at the results, where's the model still getting it wrong, and then they make corrections. They write more labeling functions to cover those errors, and they kind of repeat and rinse. So this is a workflow that we put into the web application for predictive models when we first became a commercial company in a web application, and we've used it successfully across a variety of domains and use cases. Right? But again, this is all programmatic labeling focused on predictive models. So enter generative AI. Generative AI has been around for a while, but it really exploded about 2 years ago when we all started to observe really remarkable performance from ChatGPT 3.5. And it really challenges what we think of as simple notions of what good looks like, kind of accuracy. So, on the left here, we have predictive models, which I've been discussing thus far, classifiers, information extraction algorithms, really models that produce a finite set of labels. A document is class A or B. Or, you have a document, you extract a person's name, it's this name or that name, right? We can measure the output. It's easy to say whether it's right or wrong. If model says class A and the ground truth is class B, it's wrong. If they both say class A, it's right. To measure accuracy, you just kind of sum up all the correct answers, divide by n, that's your measure. There are other ways of measuring accuracy, but it's relatively straightforward compared to something like generative AI, where you not just have input data, you have a user prompt, and you really have virtually an infinite number of possible outputs that are difficult to measure and difficult to define. And so, down here on the right-hand side, really simple example, generating emails. Maybe we have some sense of a ground truth email we want the AI to produce, and it begins with "to whom it may concern," and the AI produces "dear sir" or "madam." You know, is that the right way to begin it? Well, most people would be indifferent, some would not, some would think there's a big difference. Even really simple decisions like this can be really complicated. And how do we know what's right or not? How do we measure the correctness of the output? There are a lot of attempts in the field to simplify measurement processes by using things like rogue scores, where you look at the overlap between words. Well, as it turns out, these two phrases have zero overlap. It would score 0, yet semantically they're pretty similar. So a lot of these measures tend to fail when we see them applied to real world examples. Difficult to define. Now, often you just have to ask people, which do you prefer, or rate it on a scale of 1 to 5. You can't really use math to measure it very rigorously. So that's an important problem. And so when we first started tackling generative AI at Snorkel about 2 years ago, just thinking, okay, what's our offering here? How can we enable customers with the same value proposition, kind of scalably developing data? We decided to return to what we call first principles. And the field is changing very quickly. Lots of AI advances happening on a monthly, sometimes weekly basis. Hard to know how to predict. I get asked all the time, what do I think is going to happen over the next year? My best answer is people are going to make predictions. That's what we can count on. However, there are some things that we know to be true years, probably decades from now. Principle number 1, humans need to define what good looks like. And in the business world, that really means subject matter experts. We're building AI applications to help us, right? Not the other way around. And if anybody disagrees on that point, please chat me up later and I'll buy you a drink. We can talk about it, because that's really something we define to be true. It's a first principle. Principle number 2, kind of more specific to the corporate world, is this idea of competitive advantage. And really competitive advantage hinging on proprietary knowledge. So if you're a biotech company, you probably have a competitive advantage through your secret sauce, building medical devices or pharmaceutical pipelines. That's what differentiates you from your competitors. People are going to go to you instead of your competitor if they think you have a better kind of secret sauce. If you're an insurance company, your underwriters have their own proprietary ways of writing risk that maybe makes you more profitable than your competitors. Again, proprietary knowledge that you wouldn't want to share with the outside world. We don't think that's going away either, right? That's the kind of economy that we operate in. So let's just keep those 2 first principles in mind as we move through the remainder of the slides. Humans define what good looks like, and we have competitive proprietary domain knowledge in the business world. And just to really hammer on that first principle a little more, even if you go to these frontier AI models that work really well off the shelf, and you read those original research papers that were published several years ago, they saw that too. They really hinged their development efforts on human feedback, right? I mean, quite literally, those are in the titles of the papers. And when I read those papers, I see not only engineering success, I actually see a really big success in well-managed human workforces. Like, these companies did a really good job wrangling humans, training them to give them feedback, and being very thoughtful in the way they define what good looked like. So I actually give a lot of kudos to OpenAI and Anthropic for really doing that basic foundational research on really wrangling humans to give them signal on what would make their model successful. So now let's map that to the business world, right? What used to be a data volume problem is now really a human hours problem, right? OpenAI and Anthropic paid these people to do this work, not necessarily to produce millions and millions of examples, but to produce many, many hours into giving them high quality judgments and high quality examples of what good looks like. And so for businesses, this really, in my view, translates into a management problem. How does a business do this with their subject matter experts? And I see this in real world customer problems where maybe you have 5 to 10 SMEs and you want them to label data for you or give you good judgments. It's really hard to wrangle them. They're expensive, they have other jobs to do. And so that's really in some ways a management problem. You can contract out the work to other SMEs. Then you have to organize them. They have to learn your proprietary knowledge. So again, it's a management problem. And I don't think we can expect businesses to replicate the same managerial success that Anthropic and OpenAI did in the same way. They need to solve for scalability in ways that OpenAI and Anthropic didn't have to, at least at the beginning, right? So that's really the premise, the foundation of the research we've been doing over the past 2 years. And just to give you a preview of what we've been working on, again, I talked to you about programmatic labeling, works well for predictive models that hinge on data labeling. Whereas we've been focusing on predictive labeling traditionally, we're now looking at the more general enterprise of programmatic data development. And what we're finding is that, we need a wider array of operations. And so I'm actually showing you three of the most common ones. Alex actually alluded to this this morning. So we have data labeling, that's still relevant. Slicing is a great example of that. So maybe you have a variety of instructions that you're giving to a large model. It's really important to be able to categorize them. What are these instructions? And when we train a model, when we evaluate it, we want to know the distribution. We want to know that we're evaluating in the same kind of instruction set. In order to do that, you need to be able to categorize it, measure it in some way. So data labeling is still relevant there. So you can categorize, measure your distribution of instructions. Synthetic data techniques in the middle, instruction and response generation. We need good examples for the models of quality output. We can't expect subject matter experts to spend hour after hour generating that for the model. So it's important to enable them to synthesize that data in more scalable ways. So we've been working on that. Another kind of data operation we've been working on. And then evaluation. What's a good example and what's a bad? That's a really non-trivial problem. We see subject matter experts disagree with each other all the time, even ones at the same company. So how can we wrangle them, get them on the same page, and get them to really spell out with granularity the axes along which they evaluate and what the criteria are for what good looks like along each axis? So that's another set of operations we've been working on, evaluation. And as it turns out, a lot of the techniques that we had developed for predictive AI are still relevant. So we're not throwing everything out and starting from scratch. We're actually reusing a lot of our insights from the predictive AI work. And for example, slicing, data labeling, and evaluation turns out that we can actually use a lot of our original work on those really basic processes. Classifiers, for example, turn out to have a lot of great value here. There are other methods we're building out, but actually I'll go over some examples in a little bit of how classifiers get us a lot. And what used to be focused on data labeling iterations with error mode analysis, we're now focused on a wider array of workflows that are piecing together this wider array of operations, really focusing on the entire GenAI ecosystem and how we can fine tune and evaluate each individual component. So again, subject matter experts will define what good looks like in the GenAI world. Data labeling is still relevant. It's more of a special case. We need a wider array of operations that include evaluation, as well as synthetic data to really enable customers to develop AI well. We're doing a lot of research right now on really kind of the templates that are most useful across a broad array of domains and use cases. So I'm going to go over a couple examples just to unpack this for you. I realize it's a bit theoretical. And the takeaway now is that we're proving out the theory. It's not just a theoretical exercise. We're actually seeing this in practice. We can indeed accelerate GenAI development with programmatic approaches. Many of the original algorithms indeed still apply, so that's not just theory. And importantly, we're finding that the way in which we structure workflows is as critical as the individual algorithmic pieces. So this is not just a math exercise. This is really a user interaction exercise, and we're researching very carefully how to optimize workflows on that scale. So our first proof of concept project is with a sister startup, Together.ai. So we actually did this about 1.5 years ago when we first started scoping out solutions that we think would be relevant to customers. Red Pajama is a suite of large language models that Together.ai had released. It is based on the Llama architecture. They had fine-tuned it on about 20,000 uncurated instruction response pairs. They've been generated by the open source community, and they're really of varying quality. So some of the examples were actually shockingly bad. They looked like they'd been generated by programmers living in their parents' basement, with nothing better to do. And some were good, but some you very clearly did not want to fine tune a large model on. And so we saw some really low-hanging fruit there. How can we curate this training data and get gains in the performance of the Red Pajama models with simple processes? So that was the basic goal. And so we did this in 3 steps. First, we wrote some programmatic operators, and quite frankly, these were just classifiers. So we wrote a classifier to classify, categorize instructions. So this was an open source data set that was uncategorized. So what kinds of instructions are these? So we use categories that was actually inspired by Anthropic's work, brainstorming tasks, draft me travel plans, draft me an email. We had open question answering tasks, answer this question, who is Tom Cruise's mom, right? It's a common example, or closed question answering, here's a document, answer this question from this document. So there are a number of different classes we came up with. We wrote a classifier to classify and measure the distribution of instructions in the uncurated data. And then we built a second classifier to evaluate the quality of the output. We used a variety of heuristics looking for exclamation points and verbosity. I won't get into all the details here, but we were able to very quickly build a classifier to also assess the quality of the output. Took these two classifiers, kind of operators, applied them to the data, and then we fine-tuned Red Pajama on that curated data. That essentially now allowed us to do a comparison, an A/B test. Like, let's compare Red Pajama with the fine-tuned on the curated data with Red Pajama fine-tuned on uncurated data. And so with the results, we were able to cut the data set in half. We brought it from 20,000 instruction response pairs to 10,000. It only took us one day to write these classifiers, right? This is part of the proof of concept, is scalability. How easily could we do this? And so it was actually surprisingly easy to write these classifiers just looking at the data. And after one day of work, plus fine-tuning, we got significant gains. And so this win rate that I'm showing this slide, this is where we took these A/B tests. We took responses from fine-tuned model on our data, fine-tuned model on uncurated data, and then we actually sent them to a third-party workforce to do double-blind comparisons. Which response do you compare, or do you prefer? And we compute a win rate on which one wins, X% of the time. And what we found was on every single class, our model outperformed. It's about 5 to 10 point gains in every single class. And again, with just one day of work. So that was our proof of concept. Quickly build some classifiers to curate data, fine tune, get significant win rates on every single class. Another proof of concept, we've been expanding on that approach about 1.5 years ago. We're taking this idea of building classifiers and making it a little more sensitive to subject matter expert feedback. So for example, in fact, Fred alluded to this in the talk we were giving before. We built out a workflow in which you can take subject matter expert feedback, summarize it, feed it into an LLM as judge, look at where it's getting it wrong, and kind of repeat and rinse, providing more feedback. And so far, on one task involving coding, we've gotten a 10 to 20 point increase in the accuracy of that evaluation process just using this kind of iterative feedback pipelines. Just another example of a proof of concept experiment going from data labeling to data development. Another one on agentic reasoning errors. We're building some tools that allow subject matter experts to look at chain of thought and identify sources of errors. And we're taking all those insights from subject matter experts and turning them into what's called a state space model that can look at the patterns, on average, where do these errors occur when a model is going through its chain of thought path. So it's an example of an operator that we're introducing now, not just a workflow, but a new kind of operator. Again, just another example. Here's a customer example that I think is going to be relevant that built off of our Red Pajama work. So this is for a Fortune 500 media and technology company. They're building a chatbot to improve their customer service system. And it's difficult because it takes long engineering cycles. And importantly, they struggle to evaluate the output of this chatbot. So you can get, for example, GPT-4o to do a pretty good job as a conversational agent, just on spot checking. But then how do you evaluate how well it's actually doing over thousands of examples? UAT, user acceptance testing, is actually a difficult process if you need to look at many examples. So we're actually helping them build an automated evaluation pipeline for this. And in our initial proof of concept experiment for the customer, we actually repeated what we did for the Red Pajama project, or we followed a similar recipe where we had a customer problem classifier, so we identified classes of customer problems. We built a classifier for evaluating how good the agent was, and then we applied that to historical transcripts. And with the theory being that we could curate historical transcripts, fine-tune the chatbot to see if we could get higher quality agent feedback. And this took 2 days to build, these classifiers. And we really got huge gains in the accuracy of this evaluator if we measure it using customer happiness scores, which is an imperfect measure. And I'll actually talk about that in the next slide. But at least as a proof of concept for the customer, we're able to predict customer happiness on their historical transcripts with a 17-point increase over a baseline solution in which you just train the classifier on customer happiness. We provide a lot more signal on what makes a customer happy and what makes a good quality agent on top of the limited sources of customer happiness data that they had. And importantly, this model even outperformed ChatGPT 3.5. So this is a year ago. That was the best at the time. We got 7 points of increase in accuracy over ChatGPT 3.5 when you give it a naive prompt about how to assess the quality of an agent. Importantly, the output of ChatGPT was a part of our programmatic evaluation. It's not an either or. You can take the output of a language model like ChatGPT and actually include it in your operator and just provide signal on top. Where is ChatGPT getting it wrong? How can we improve? And that's essentially what we did. We saw the errors it was making and got significant increases in evaluating agent quality using feedback from the experts we were working with at the media company. Since then, we've been working with the customer more diligently to build out a more sophisticated evaluation pipeline. And in fact, we're using now large models as part of that pipeline, where this is some of what I showed you before in the pure research realm, where you can take more feedback from the subject matter experts, summarize it, build it back into the programmatic operator, and get significantly and incrementally more increases in accuracy for the evaluation. And then the next step for this customer is going to be distilling into a lightweight model. They can put it into production. That's going to allow them to essentially put guardrails on the chatbot and identify in real time whether a conversational agent, AI agent, is doing a good job. So again, the takeaways: subject matter experts define what good looks like in a Gen AI world. Gen AI development can be accelerated by programmatic approaches. A lot of our original approaches still apply, and we're just kind of building on top of that. We're not starting from scratch. And importantly, development workflows are as critical as the success of the algorithmic pieces. And to that end, I'm going to actually hand it over to Angela, who's going to show you how we're actually doing that on the product end, because they're taking our learnings and figuring out what are the proper abstractions that we can then bring to our broader customer base so we can replicate these successes in ways that aren't just kind of one-off examples with customers.
Yeah. Right. Thank you. Hi, I'm Angela. So far we talked about the first principle, right? That the human and the proprietary knowledge. And we have also heard from Chris many exciting examples where the research team has worked with customers actually proved the value of this AI development workflow. So at this point, it's like, so what does it look like to work with Snorkel? So let me introduce you to SnorkelFlow. So SnorkelFlow is our programmatic AI development platform that makes AI data development as efficient and programmatic as software development. So here I'm just looping some few screenshots from SnorkelFlow platform to kind of give you a sense of what it feels like. But to really help you understand what it works, I do want to spend the rest of the talk walking you through an end-to-end demo of a SnorkelFlow iteration loop. So I'm actually going to demo, if you're a Snorkel customer, we're actually going to demo a new use case that we've been working on. So this is actually the first time we're sharing this externally. Exciting. And that is prompt development. So folks, raise your hand if you or your team has been working on prompt development or prompt engineering. Okay, I'm seeing a few hands up. Okay, well, so let's see if this business case will resonate with you. So imagine you're a data scientist in the banking industry, and you're working on a personal finance chatbot. So your team is asking the question of, can we prompt LLM to generate quality answers to common banking questions, given the relevant context, right? So in this case, you have a data set that has 100 FAQs and it has some relevant context. You don't have any ground truth answer, unfortunately, but you do have limited access to SME who can help you with the development process. So with your data set, you can go into SnorkelFlow and kind of jump straight into some of the data operations you have in mind. So here I'm showing, this is SnorkelFlow platform, and you can go ahead and straight create an application. In this case, we're creating a prompt development application. You are going to upload your data set, and you can define your LLM that you want to use and define some parameters, and also include a number of these metrics and evaluators like what Chris was talking about, and can immediately start going into the prompt development environment. So landing in this page on the left-hand side, this is where your prompt composer is, and this is where you can see all of our statistics. And in the middle, this is your data set. So this is the frequently asked questions and the context that you have. On the right-hand side, this is where you can see the responses after each run prompt and also all of the evaluators that you have at your hands. So you just want to jump straight in. Like you have your question, you want to get the response. So like, what is Ellen looking at out of the box? So you can see it's not doing so great as expected, right? So then you're going to like, you have some basic prompt techniques like you want to define your roles. And in this case, okay, well, this is the customer representative and blah, blah, blah. So very basic, right? You want to run a prompt again and see how it has improved. Okay, well, you're starting to get into it, but now we're actually utilizing all the evaluators that you have. In this case, one of your evaluator is saying, hey, adding some actionable details. So you're kind of looking at your data set and be like, okay, well, I guess I can try to like make sure that it is referencing some of the numbers, some of the dates and important information. So then I can run the prompt again. And here, you may see some improvement, right, depending on the writing of your prompt at this point. So you can imagine how you're going through using this platform to go through the loop. At some point, you're going to be hitting a wall, and then that's probably when you need to start asking a subject matter expert for feedback. So let's see what it looks like on the platform. So we're back to the prompt development page. So I'm in version 1558. Again, I actually go ahead and see all of the progress I've made. Every time I run prompt, we autosave. And you can start the prompt that you have so that you can find it easily later. So very easy in how can you bring this set of information? So I can go to the table and select all of my data, and now I can create a batch. So here I can actually specify what kind of feedback I would like to get from my subject matter expert. So in this case, I want a binary accept or reject. I would like to ask for a rationale, and I can also assign to a specific annotator of that I have in mind. So just like that, it is sent to the annotator. On the annotator side, what is their experience like? On the same platform on SnorkelFlow, they can go straight into the annotator batch. So they can see all of the batches they're assigned. So in this case, to find a data set, they can go jump in straight into annotate. So in the environment, they have all the data, the questions, the context, as well as the answers that you would like them to provide input. So in this case, they're looking at it, it's like, this is still not quite good. I would have done it differently. I would have included some bullet points. I probably would like think that like it will include some links so I can directly go straight into the help that I need. And they can go to the second data point and can do the same thing with a consistent experience. So as our SMEs start to provide feedback, let's see how you can access and utilize this feedback in your prompt development environment. So we're back again to the development interface, and you can simply open the SME feedback pane to see your feedback. And you'll notice that like it is side by side with your response, and it also has all the historic feedback that this SME has provided for this data point. And this is important because it can help you understand all of the track record and the context you have. So in this case, let's say that the feedback that we're just talking about, like, formatting a little bit better, right? So I can internalize it and turn it into a guideline that I want to include in my prompt. So I'm going to go there and then I will essentially say, hey, like, reader-friendly format and all that stuff. And I can start running the prompt again. And maybe I see some improvement. But to really see the differences of improvement, I would like to see the two responses side by side. So again, you can run your prompt and you see the responses and with the subject matter feedback and your previous version, just right at your fingertips. Okay, so far we've been mostly looking at the workflow that is very focused, right? Like a very micro, very per data point of view. But since we're working with a large data set, it's important to evaluate the prompts across the data set and make sure that the prompt is performing well on different data slices. So how do we do that? We're back to this application. In this case, I'm actually going to a different page called evaluation. We open this page, we can immediately see its progression of your performance across the different prompt version, and not just on all data, but also across different data slices. Then these data slices might be your business requirement. So at the bottom, you'll be able to see per prompt version, what is the performance looking like across your different slices, across the evaluators that you have. And I can actually go ahead and compare versions. So in this case, you can kind of see, you can kind of like start to define a pattern of like, where the problem might be. So in this case, I'm looking at a financial service slice, and it seems like there is some interesting growth in some areas and then drop in some other areas. So I'm going to click into it. As you click into it, you can directly go back to your data development environment, with the specific slices and with the same thing we talked about, responses side by side, SME feedback on the side, everything that I have in my fingertips to help me iterate. So we just kind of walk through an example workflow of this flywheel for a Gen AI problem. And yes, I think that we did spend a lot of time and center our narrative around these three key nodes, like the data operations, the SME collaboration, and evaluation. But in working with our customers and developing the workflow, we know that the toughest thing is actually to make this flywheel productive and healthy. And how do we do that? The investment is also on the connected tissues between these nodes, so that you can make sure that you're not getting stuck in going from one stage to another stage. So this means a range of things, right? This in the case of prompt development, it means that we can manage and tune our prompts well in a platform. This also means that we can have a very seamless way of collecting and utilizing these feedback on the same platform. And at the end, I didn't touch upon this a lot, but we will talk about it in the future talk, is you can develop and fine-tune the evaluators on the same platform as you're developing your business problem. So that concludes the whole walkthrough. And in our technology track today, it's super exciting that our colleagues will be sharing a lot with stories on different types of use cases. So we have Jennifer, she's going to talk about the PDF documents. We have Rebecca and Venkatesh talking about LLM eval deep dive. And we have Ryan giving you a lot of tips on RAG. And finally, Marty and Amit on fine-tune LLM. So if you want to learn more about SnorkelFlow, we do run virtual demos, like live demos, I think every other week, I believe. So we can sign up right here on our website. And whether you're an existing SnorkelFlow customer or not, like we really would love to hear from you. Really, like learning with our customer is the best way to make sure that make sure our product is serving you well. So please sign up for user testing. We're really excited to chat with you. And finally, thank you.